Hello dear students, so I'm back with the next session of our basic mathematics course and let's me start right away. We are continuing with vectors and before I start I would like to request all of the students who haven't subscribed the channel yet to please subscribe the channel. It helps us to see that you guys are following us and we are able to help you out. On that note, let's begin. So right now we are covering the vectors chapter and in this chapter what we have covered already is this terminology and addition. Today we are going to talk about this topic, vector, unit vector and resolution. All right. So without wasting any time, let's start guys. Okay. So what exactly is a unit vector? So I'll tell you that a unit vector, okay, unit vector is a vector having magnitude of unity. Okay, now this is very interesting. Like a unit vector is a vector having a magnitude of unity. It means that the magnitude would be 1. Okay, and we use unit vectors to depict directions. Okay, unit vectors are used to depict directions. Okay, so let's say if this is a vector and if this is a unit vector, okay, normally we represent vector by this notation, like we put an arrow overhead over the symbol that represents the vector. But in case of unit vector, if this is a unit vector, then the norm is to put a cap, all right, cap over the symbol instead of putting a arrow. A cap over the symbol tells us that not only does A represent a vector, it actually represents a unit vector. Okay, so unit vector is a vector having magnitude 1. Okay, now let's talk about what a unit vector is. A vector having the primary purpose of unit vector is to indicate direction. Okay, and so whatever I have told you right now, that is present on the screen so that you can take note of it. Okay, and what I haven't tell you till now, I will tell you now. So guys, the unit vector along x direction, okay, like for example, if this is x-axis, let's say if this is y-axis, and let's say if this is z-axis, then the unit vector along x direction, okay, it is represented by I cap. It is an internationally accepted convention that I cap would represent a unit vector along the x direction. Similarly, j cap would represent a unit vector along the y direction, and k cap would represent a unit vector along the z direction. Okay, so that is what is written here, that a unit vector along x, y and z are represented by I, j and k respectively. Now how does it help us? We'll try to understand with this example. Suppose I want to write a displacement of 5 meter along positive x direction. Okay, so whatever has been written in English language here, how can I represent it mathematically? This can be represented as 5 I cap meters. You can put the unit after this. Okay, so 5 I cap meter or 5 meter I cap, it doesn't matter, like whether you are putting the unit before I cap or after I cap. Okay, so both are correct. So a displacement of 5 meter along positive x direction will be represented by this. A force of 20 Newton acting along positive x direction. So this would be represented as 20 Newton into I cap. Okay, now can you try that what would 15 j cap meter per second will represent? If you have guessed it, yes, it would represent velocity of 15 meter per second towards y direction, because we are using j cap here. So it would mean velocity of 15. How do I know its velocity? By looking at the unit. Why aren't you saying, like, sir, why aren't you saying it is speed? Because speed is a scalar quantity and this definitely represents a vector. So it has to be velocity. Velocity of 15 meter per second along the y direction. Okay, now let's see if we can draw these force vectors. So here are some force vectors that you see. Okay, F1, F2, F3, F4. Okay, now you see them clearly. Okay, so if I want to draw F1, let's see how do we do this. So let's say this is x-axis, let's say this is y-axis. Okay, now what are we expected here? I will draw minus 15 I cap. Now minus 15 I cap tells me that I have to move 15 units along the negative x direction. So it would be like this, like starting from origin, I will travel 15 units along the negative x direction. Okay, and then 20j, so 20j would be this. All right, so these two yellow arrows, all right, this is the first yellow arrow, this is the second yellow arrow. These are two vectors, these are two independent vectors. This one is a vector of magnitude 15 in the negative x direction. This is a vector of magnitude 20 Newton in the positive y direction, and the sum of these two will represent F1. Now from the triangle law of vector addition, we know that these vectors are properly arranged right now. The head of one lies on the tail of next, all right. And if we join the free tail with the free head, that is, if we join the free tail with the free head like this, then this would represent the F1 vector. So we have now represented F1 vector. All right, you can try with the next one also, like how do we represent F2 vector? So for F2 vector, okay, let me draw another figure. uh, we can do it here maybe. Okay, so this is x, this is x, this is y. So F2 is minus 6. Okay, so minus 6 would be somewhat like this, minus 6 I cap, and then minus 8 j cap. So now 8 units in the negative y direction. Okay, so this is 6 unit, this is 8 unit, and adding these two arrows. Now again, remember, these two arrows are properly arranged. The head of one lies on the tail of the next, and therefore if we join the free tail with the free head, this would represent the F2 vector. Okay, can you think of drawing the F3 vector yourself, everyone? Okay, let me do it here, let me do it in this figure. So plus 5 I cap, okay, this is 5 I cap, and then 10 j cap, something like this. Okay, so F3 vector would be somewhat like this. This would be F3 vector. This is 5 and this is 10. Okay, ignore the fact that this 10 and this 20 are, almost same. Ignore that. Then this is F4. This should be F4. So F4 is 5 I cap and minus 7j. So 5 I cap will be same as this. Okay, this is 5 I cap. Then minus 7 would be somewhat like this, and therefore the F4 vector would be like this. Okay, so this would be F4 vector. So I hope you understood that when we represent a vector like this, how do we draw them? Okay, if this part is clear, let's proceed. So this is, I've drawn F1 and F2 for you. You can try F3 and F4. Now let's talk about what a position vector is. So let's say position vector of point. So let's say there is a point P, or let me explain it here, or maybe here only. So P is a point, all right. So what does the position vector of P means? Position vector of P means a vector which is drawn from origin towards this point. Like the tail of the vector will be at the origin and the head of the vector will be at P. Such a vector is called position vector of P. We generally represent it as RP vector, R with a subscript P, or another way to represent it as, to write it as OP vector, all right, where O represents the origin and P represents the point. So, on the top of O, you see the tail of the vector. On the top of P, you see the head of the vector. So, OP vector means a vector whose tail is at O and whose head is at P. All right. Now, let's check an example. Suppose this P point has coordinate of, let's say 4, 5. Okay, what would that mean? That would mean that we have to travel 4 units along x direction and then 5 units along the y direction to reach this point. All right, and also notice that this point can be, this arrow can be written as 4 I cap and this arrow can be written as 5 j cap. So the position vector, that means this vector, okay, this vector which will be the sum of the two red arrows, okay, that means RP vector, it will be written as 4 I cap plus 5 j cap. Okay, in other words, we can make a thumb rule that if P point, if any point has coordinates of x, y, z, all right, then the position vector of that point can be written as x I cap plus y j cap plus z k cap. Okay, this would be the position vector. So you can remember it. I'll present it in the summary also. But if a point has got coordinates of x, y, z, then the position vector of that point can be written as xi cap plus yj cap plus zk cap. Please remember this. Okay, now what exactly is the relative position vector? So let's say we have 2 points. Okay, let's say point A and let's say point B. Okay, now a vector connecting point origin to point A will be called position vector of A. Vector connecting origin with B will be called RB vector, that is position vector of B. Now, if I want to talk about position vector of A, with respect to B. Okay, position vector of A with respect to B. It means that if you are standing at B, then where will you look and how far will you look to see a point, or where will you travel and how far will you travel to reach the point A. So that is position vector of A with respect to B. So right now this is the vector that we are talking about. This is the position vector of A with respect to B. Alright, and how do we denote this vector? One of the way is to write it as BA, because the tail is at B and the head is at A. Another way is to write it as RAB vector. Okay, another way is to write it as RAB vector, that is position vector of A with respect to B. This we can avoid this, this will probably confuse you. Okay, so it actually depends on how the person has described. Okay, so if I'm saying that the first alphabet will represent the head and the second as tail, then we can write it as like this. Okay, so notice that here and here the order is different. Here it is position vector of A with respect to B, and here we are writing position vector like the whatever we are writing first, that is head, and whatever we are writing next, that is tail. Okay, so these are the two ways to represent it. Now if you notice carefully, these three vectors are making a triangle. Pay attention that these three vectors are making a triangle. Okay, and in this triangle, can you figure out that which one will be called as the resultant? Alright, if you ask me, the head of RA vector coincides with the head of another vector, and the tail of RA vector coincides with the tail of another vector. So RA would be the resultant vector. In other words, RA vector will be equal to RB vector plus RAB vector. Okay, or we can rearrange this, that RAB vector will be given by RA vector minus RB vector. Okay, and what does this tell me now? What does this tell me? Suppose if A point has a coordinate of xa, ya, za, and B point has coordinate of xb, yb, zb. Okay, then RA vector, that is position vector of A, that would be written as xa I cap plus ya j cap plus za k cap, and position vector of B will be written as xb I cap, it's I cap actually, xb I cap plus yb j cap plus zb k cap. And now when we do RA vector minus RB vector, how do we do this? How do we take the difference? So what happens, guys, you have to use your rules of algebra. Okay, what does rules of algebra indicate? See, we will first write xa, like let us just substitute xa, RA and RB first. So it's xa I cap plus ya j cap plus za k cap, okay, minus xb I cap plus yb j cap plus zb k cap. Okay, and then what you can do, you can collect the coefficients of I cap. Now coefficients of I cap are xa minus xb. Similarly, coefficient of j cap, okay, similar to what you do in algebra, that would be ya minus yb, and then finally k cap would be za minus zb, and this will give you the position vector of A with respect to B. Alright, so this is how we get the relative position vector. Okay, I hope this is clear now. This is how we, now let's try something, guys. Let's try an example related to whatever we have learned. So let's say this is x-axis, let's say this is y-axis, let's say this is z-axis. Okay, and let's take a cuboid. Okay, let's take a cuboid. Okay, and let us mark some lengths on this cuboid. Let this be 5, let this be 3, let this be 2. Okay, let this point be origin A or O, then this point be A, this is B, this is C, okay, this is D, E, let's say F and G. So these are the points. Okay, now tell me, students, if I ask you to write the coordinates of these points, will you be able to do that or not? Okay, let's start from origin. So if I try to write the coordinate of origin, will you agree with me that it would be simply 0, 0, 0? Alright, now if I try to write coordinate of A, can you do it everyone? To move to A from origin, we have to travel along the x-axis only and we have to travel 5 units. So it would be 5, 0, 0. Okay, if we try to write coordinate of B, okay, to reach B point, we'll have to travel along x-axis by 5 units and then along y-axis by 2 units. So 5, 2, 0. Okay, to reach C point, we only need to travel along the y-axis and by a distance of 2. So 0, 2, 0. Okay, to reach D point, we have to travel along y and then we have to travel along z. Okay, so along y we need to travel 2 units, along z we need to travel 3 units. Okay, because this length is 3. So that is the coordinate of D. What about the coordinate of E? To reach E from origin, we just need to travel along z axis. Okay, that too by a distance 3. So it would be 0, 0, 3. Then F point, okay, to reach F point from origin, we need to travel along x, then along z. We don't need to travel along y. So the coordinates would be 5, 0, 3. Okay, and then G. Okay, G, the coordinate of G, that would be 5, 2, 3. So we have written coordinates of each point. Now let's say if I ask you to write position vector of any of these points. Let's say I ask you to write position vector of B. Okay, I ask you to write position vector of B, RB vector. How do you do it? Simply check the coordinate of B, 5, 2, 0. So it would be 5i cap plus 2j cap plus 0k cap. You can avoid writing the 0k cap. So it would only be 5i cap plus 2j cap. Alright, and likewise you can write position vector of all other points. For example, if I want to write position vector of G, okay, then the coordinate of G are with me. I will write it as 5i cap plus 2j cap plus 3k cap. That would be the position vector of point G. Okay, now there is another very important thing to notice here. Suppose I want you to calculate the length of this arrow, that is the magnitude of RB vector. Okay, I think you can easily calculate it by using Pythagoras theorem. You notice that these two lines, they make a right angle triangle and this is the hypotenuse. So it would become 5 square plus 2 square root of that. Okay, and if you notice here, 5 square plus 2 square, so we can actually make a general rule that if there is a vector, which is represented by something into I cap plus something into j cap plus something into k cap, then the magnitude of that vector denoted by this, okay, this notation is to indicate magnitude of the vector. Okay, magnitude of vector, okay, which is also denoted by only the alphabet without the putting the arrow overhead. This is also magnitude of vector. This is root of the square of x component plus the square of y component plus the square of z component. This is how we find out the magnitude of any vector. Please remember this. Okay, magnitude of any vector is obtained by root of ax square plus ay square plus az square. That gives you the magnitude of the vector. Okay, so coming back, if I want to know, suppose I want to know that what is the distance between, let's say, okay, let's continue with this example. Suppose I want to mark the midpoint of the top face, let's call it as x. So, and I want to mark, let's say, the midpoint of this right face, let's call it as y. Okay, so first of all, do I know the coordinates of x? Try to get it, everyone. So x is the midpoint of the top face. Okay, to reach x, we first need to travel this much distance along about 5 by 2. Okay, we need to travel 2.5 along x-axis. Then we need to travel till the top, that is 2 units along the y-axis, and then we need to travel half of that, half of 3, that is, so 1.5. So this is the coordinate of x. Okay. Similarly, if we want to write coordinate of y, y is the midpoint of this face. So we'll have to travel all along the x, so that is 5, and then I'll have to reach the midpoint of this edge, so that would be 1, and then I have to again travel half of the length of along the z axis, so that would be 1.5. Okay, and now if I want to know the distance between x and y, okay, geometry, by looking at the figure, probably I can try to calculate, but it would become easier. See, if I want to calculate the distance between x and y, it basically means that I want to calculate the magnitude of this arrow. I want to calculate the magnitude of arrow xy. So what we can do, we can first try to write the xy vector. Okay, I'll do it here. We can first try to find out xy vector. How will we do it? We will write ry vector minus rx vector. So let's do it. So coordinates of y minus coordinates of x. So 5 minus 2.5, that would be 2.5 I cap. Okay. Then 1 minus 2 would be minus 1 j cap. Okay. And then 1.5 minus 1.5 would be 0 k cap, so we need not write it. So this is the vector. Now the distance between x and y is magnitude of this vector, which is 2.5 square plus 1 square root of that. So this will be the answer. This will be the distance between the two vectors. So I hope you understand that how we can use the concept of magnitude to find out distance between the 2 points. You find out the relative position vector of one point with respect to other, and then you calculate the length of that arrow. That is the magnitude of the vector by using this formula. Alright, now if this part is understood, next we are going to talk about resolution. So dear students, resolution is one of the most important step that you will learn in vector, in vectors chapter. So what exactly is this? Let me try to explain that. So suppose you have a vector A. Suppose you have a vector A. Alright, and now if I ask you to draw, let's say, two vectors such that the sum of those two vectors will become a vector. So I want you to split this vector into two parts, or let's call them as components. I want you to split this vector into two components such that the vector addition of those two components gives us a vector. Let's see if we can do it or not. So I think if I draw a horizontal line like this, until I reach the bottom, the vertically below this head. Okay, I'll extend this arrow till this, and then if I draw an arrow like this, so I do believe that I have split vector A into, let's say, A1 vector and A2 vector, and I do believe that I can write A vector as A1 vector plus A2 vector. Notice this. Okay, so this process is called resolution. Resolution is splitting a vector into multiple vectors such that the sum of those multiple vectors, the resultant of those multiple vectors, will give us the original vector back. Okay, let's understand this. When we are calculating the resultant of multiple vectors, we are combining the vectors so that we get one single vector that can have the same effect as all the vectors combined. In resolution, we are doing the opposite. We are splitting one vector into multiple vectors so that the set of those multiple vectors can have the same effect as this single vector was having. So right now I have resolved, the process of resolution is called I have resolved this vector into two components, A1 and A2. Okay, now let me ask you, can I find another pair such that the sum of those two will become equal to a vector? Well, I do think I can do this. Okay, some of you might be thinking, okay sir, I know, let's draw a line like this and then let's draw a line like this. Well, you are correct actually, but this is not a different pair in true sense. Using the property of invariance, we can very well judge that this green vector is same as A2 and this green vector is same as A1. So essentially these two vectors are same. So this is not a new pair. This is again the same pair, A1 and A2, drawn at different place, using the property of invariance. So let's not worry about this. Let's try to look for any other pair, any pair other than this. So does anything comes to your mind? I think there is something on my mind. Let's see. So what if I draw an arrow like this and then I draw an arrow like this? So I do believe that the sum of these two arrows will give me a vector. Okay, or maybe I can draw an arrow like this. Okay, and then I can draw an arrow like this, or maybe I can draw an arrow like this, and then, so probably you have judged it by now that you draw any random arrow. You start from tail, you draw till any point in any direction, and then wherever you want to stop there, and from this point just connect to the head. Okay, you from this point just connect the head, and yep, this is your, so sum of these two. So we have seen that we have resolved vector A into multiple pairs. Can I resolve vector A into three vectors instead of two vectors? Well, let's try to do that. So if this is a vector A, I want to break it into three vectors. Can I do that? Let's see. I'll probably start with tail. I'll draw a vector, I'll draw another vector, and then I will draw the closing vector. That means I will draw two vectors randomly, and then I will draw the third vector such that it ends at the head of A, and that will give me a triplet. So these three vectors when added will give vector A. Can I draw any another triplet? So let's see. I may do this, then I may do this, and then I may do this. So yeah, So these three vectors again, they add up to give vector A. So I think by now you might have judged that if we want to resolve, that is, if we want to split a vector into n number of vectors, we can do that. When I say n, what do I mean? Basically, you can choose. You can choose to split a vector into 2 parts or 3 parts or 4 parts and so on. So it is your choice. So first point that you have to keep in mind is that a vector can be resolved into any number of component. It can be resolved. Whether we do that or not is our choice. I'm not saying that resolving a vector into 100 components or 10 components or 5 components will help us in any way. It may help us, it may not help us. If it helps us, you can do that. If it doesn't help us, why would you do that? Okay, I'm just talking about the ability. Can we do that or not? Yes, we can do that. If we feel that it is going to be helpful for us, we can do that. So keep this in mind. A vector can be resolved into any number of components. These individual vectors are called components. Much like the components are parts of a bigger assembly. So this vector is like the final outcome that we are getting, and the parts into which we are splitting them, they are called the components. Okay, so a vector can be resolved into any number of components. That is the first point that you need to keep in mind. I'll probably write it also in a few moments. The second point that you need to keep in mind, let's say I've chosen the number of components I want to make. Let's say I want to make 2 components. The moment I have fixed my n, I have decided that okay, I want to make two components. All right, how many such pairs exist? What do you think, guys? If you have decided that into how many components you are trying to break the vector, how many such sets will exist? I think there are going to be infinite sets. Okay, if I want to split this vector into a couple of vectors, I have infinite ways of doing that. If I want to split this vector into a triplet, if I want to break it into 3 vectors, I again have infinite ways of doing this. You can see how infinite, like you can start from anywhere, you can draw till any point, you can then draw till any point, and then you can end. So you have infinite ways of doing this. Okay. So we can resolve a vector into any number of components. Once we have decided that how many components we are going to make, there are infinite ways of getting those many components. Okay. Now, out of these infinite ways, it's not that everything is helpful for us. The general tendency is to split a vector into a pair. That is the most useful situation for us. So although we can split it into 3 and 4 parts, we generally split a vector into 2 parts. Okay. So let's focus on this. So we generally split a vector into 2 parts, and in that also we try to find a pair such that the 2 vectors are perpendicular to each other. For example, this is vector A. I said that okay, split this vector into 2 parts and ensure that the 2 parts are perpendicular to each other. So let's say if I end up drawing 2 vectors like this, no, this does not satisfy my requirements. I said that I have to split this into 2 parts and the 2 parts must be perpendicular to each other. So right now this pair doesn't serve my purpose. Let's think of another pair. All right, so I'll probably draw one vector like this, another vector like this, and yeah, this serves my purpose. So I see that the two vectors are perpendicular to each other. Okay, so I have definitely found a pair. If I have definitely found a pair such that the 2 components in the pair, they are perpendicular to each other. Okay, now my next question is, can I find another pair? Can I find another pair such that they are perpendicular to each other, like the components are perpendicular to each other and yet they give us vector A? Can I find another pair? Now those of you who are again thinking, sir, another pair this is the only possibility, then again you are wrong, because this is the same possibility. This is not another pair, this is the same pair. Okay, this is again A2 and this is again A1. So no. Can I find any other pair? Any other pair? Let me think of it. So I think that I can just start drawing a random line. Okay, and then I can, from the head, I can drop a perpendicular to this line, and I think I have found my pair. What I can do, I can draw an arrow like this, and then I can draw another arrow like this. So yes, I have definitely found another pair. Okay, can I find a third pair? Of course, you can repeat the process. Okay, you can again draw any random line, and then you can drop a perpendicular on this line from the head. Okay, and then what you can do, you can then draw one vector like this and another vector like this. So let me reiterate. If I want to split a vector into a couple of vectors, how many such pairs exist? Infinite. Out of these infinite pairs, if I am looking for the pairs in which the two vectors or the two components are perpendicular to each other, how many such pairs exist? Even they are infinite. Getting it? We have infinite ways of splitting a vector into a couple of vectors. Out of those infinite ways also, there are many pairs in which the two vectors will not be perpendicular to each other, and there will be many pairs in which the two vectors will be perpendicular to each other, and the count of such pairs is also infinite. Okay, and this can be proven by another method also. We can prove this by using property of circle also. So whatever vector I have given you, suppose I have given you this vector, a vector, and I have asked you to show me how we can split it into pairs such that the components are perpendicular to each other. What I will do, I will say that, okay, let us draw a circle. Let us draw a circle such that this vector becomes the diameter. Okay, I will say that let us draw a circle that this vector becomes a diameter. And now what you have to do, you have to just start from the tail, join the circumference. Then so we know that the circle has this property that the diameter subtends a 90-degree at the circumference. All right, so any pair that you will draw now, starting from the tail, hitting the circle, and then joining the head, all such pairs, all right, the two vectors are going to be perpendicular to each other. So from here also we can see that we can find infinite pairs such that the two components are perpendicular to each other, and this is the most useful situation for us. How useful, that I will show you in a short while. So for that, let me show you. Okay, so what is the task now? The task is that, let's say I have a vector, a vector, and I want to split this into two components such that one is along this line, the other is along this line. Okay, so let's say this length, okay, this is a1 vector, let's say this is a2 vector. Okay, so suppose we know this angle theta, we know this angle is theta. Okay, notice this, guys, since this is right angle, cos theta will be written as the length of this vector, which is a1, divided by the length of hypotenuse, which is a. In other words, a1 can be written as a cos theta. Okay, similarly, if I were to write sine theta, it would have been a2 divided by a, or in other words, a2 would have been a sine theta. This is the most important thing for you to learn. Okay, if we are trying to break a vector into two components, all right, and we know that the angle this vector makes with one component is theta, all right, then this particular component will be given by a cos theta and the other will be given by a sin theta. All right, so a cos theta, a sin theta. Okay, please learn this, I'll show you how to use this. Okay, I'll show you how to use this. So let's do an example. Okay, let's do an example. Suppose I gave you a force, of 100 Newton, and I told you that it is making 37 degree with x-axis. Okay, let's call this force as F vector. Okay, now I have asked you to write F vector in terms of I and J. How will we do that? So what we can do, we can draw lines like this. So this one and this one we want to write. This length will be how much? This length will be 100 cos 37. We just saw this. Okay, 100 cos 37. So this would be 100 into 4 by 5. Cos 37 is 4 by 5. I hope you remember that. So this will become 80. Okay. Similarly, this would be 100 sine 37, and sine 37 is 3 by 5. So 100 into 3 by 5. So this is 60. So we know that this length is 80 and this length is 60. Therefore, F vector can be written as 80 I cap, okay, plus 60 j cap. This is how we can write F vector, 80 I cap plus 60 j cap. Okay, so that is how we have split this vector into two. Okay, let's try one more example, everyone. Let's try one more example. So suppose this is the coordinate axis and we have a force something like this. Okay, we have a force something like this. Let's say this force is 80 Newton, and let's say this angle is 45 degree. Okay, what do we do now? So we have to, like, one component will be like this and the other component will be like this. I hope you are able to judge this. Okay, so this length would be 80 cos 45. So that is 80 into 1 by root 2, and even this length will be 80 sine 45, which is same as this. So how do we write this vector? This vector will be written as 80 by root 2, 80 by root 2. Notice the direction, it is minus I cap. Okay, minus I cap, and 80 by root 2. Notice the direction. This direction is plus j cap. Okay, so plus j cap. Okay, and there's one more thing, guys. It is not necessary that you have to draw arrow here only. You can draw this arrow here also. Okay, like one component like this and the other component like this, because of the property of invariance, it is okay to draw the arrow here or here, where you can draw wherever you like. Okay, this method, drawing along the axis, will be more beneficial to you when we do the questions. Now, if you have learnt resolution, let's see how we are going to use resolution. So, let's see a problem here. So, in this question, you see 4 blue colored arrows. They are all forces: 40 Newton, 30 Newton, 20 Newton, 50 Newton, and their angle with different axes has been given. So, this 40 Newton is making 60 degree with the x-axis. This 30 Newton is making 53 degree with the y-axis. This 20 Newton is making 37 degree with the negative y-axis, and this 50 Newton is making 30 degree with the positive x-axis. So the angles are given, and now we have been asked to find the sum of these 4 vectors. Okay, now we have learnt finding the sum of vectors earlier also, but what we learnt at that time was finding the resultant of a couple of vectors. This is what we learnt, how to find resultant of a couple of vectors. Right now we are not talking about a couple, we are talking about 4 vectors. Okay, now you will acknowledge this, that if I proceed like this, like first I will find sum of these two, I will get a new vector, then I will find sum of that vector with this vector, I will again get a new vector. That is going to be a very lengthy process. Okay, so we are not going to do that. We are not going to do that. We are not going to, proceed by making pairs. Okay, like resultant of 1 and 2, then whatever we get resultant of that and 3, then whatever we get resultant of that and 4. No, that is not the brightest of approach. The right approach would be that we first resolve all the 4 vectors into pairs. So we first split this vector into 2 vector, we split this vector into 2 vector, we split this one into 2 vector, we split this one into 2 vector, so that instead of 4 we will now be having 8 vectors. Doesn't seem very wise, does it? That instead of having, we were trying to reduce the number of vectors from 4 to 1, and I'm asking you to change the number from 4 to 8. Well, it may look that it is not the right idea, but it is actually, so when you resolve these vectors, let's see what will happen. So to do that, we will first resolve the vectors. So let's see, guys. So this 40 Newton will have a component along x-axis. Okay, so I'll draw it here. So one component will be along this, and you will acknowledge this angle is 60, this is 40. So this component would be 40 cos 60. Okay, this would be 40 cos 60, which is actually 20. Cos 60 is half. Okay, and the other component will be in this direction. It will be along positive j, and how much will it be? It would be 40 sin 60. So this component, I'm directly writing 40 sin 60 would be 20 root 3. So what we have done, we have taken care of this vector. Instead of this vector, I have now drawn a couple of vectors which will play the same role as this vector. So let's forget this. Okay. Next we have this 30 Newton vector. This is 30 Newton making an angle 53 degrees. So the component along this, because the angle here is 53, so the component along this is 30 cos 53. Okay, so we will have an upward component 30 cos 53. So 30 cos 53 is 3 by 5. So it will become 18. Okay, and similarly this vector will have a negative x component also, that would be 30 sin 53. So in this direction we have a component 30 into sin 53 is 4 by 5. So it will become 24. Okay, so we have taken care of this vector also. Okay, we have resolved this vector also. Now let's take care of this vector. So here what we are having, this is 20. So we will have a downward component. You can see that one component will be in the downward direction, and because this angle is 37, so this component would be 20 cos 37. Okay, so it would become 20 into 4 by 5, so that is 16 Newton. Okay, and then the another component will be in this direction. This would be 20 sin 37. So 20 sin 37 is 3 by 5, so it will become 12 Newton. Okay, so we have taken care of this also. So we have removed 3 vectors, we have made 6 vectors. Now the last one. So 50 cos 30 would be 25 root 3, and then in the downward direction we can see that would be 50 sin 30, so that would be 25. Okay, so now what we have done, we have split the 4 vectors into 8 vectors. Okay, now how does it help us? If you notice carefully, among these 8 vectors, we have vectors which are either parallel or anti-parallel to each other. Okay, so all the vectors which are along y-axis, they will get added or subtracted among themselves. So these four vectors. So upward we have 20 root 3 and 18, and downward we have 16 and 25. Okay, let me see whether I'm yes. Okay, so the net upward value that we will get will be 20 root 3 plus 18. Okay, let me write it here. So the net upward component will be 20 root 3 plus 18. They are both upward, so that get added up, minus 16. Okay, minus 16 and 25, I guess. 16, it was this, and 25. Yeah, 25. Minus 25. So this is how much? This is 20 root 3 and then minus 23. Please check the calculations. Okay, there may be some error in the calculation, but yeah, just check it. Yeah, this seems right. So I have a single arrow now pointing in the upward direction, which is 20 root 3. 20 root 3 minus 23. 20 root 3 minus 23. Okay. And similarly, we will add up all the vectors along the x-axis. You know, add and subtract depending upon their direction. So all such vectors. So in this direction, we have 20 plus 25 root 3. I'll write it here. 20 plus 25 root 3. Okay, 20 plus 25 root 3 minus 24 minus 12. So how much is this? This is 25 root 3 and minus 16. 25 root 3. So we have another arrow in this direction. Okay, 25 root 3 minus 16. So you see the beauty. From 4 we got 8, from 8 we were able to get 2. And notice that after this step you will always end up with 2 vectors. Okay, one vector corresponding to all the vectors existing along the y direction, and the other corresponding to all the vectors existing along the x-axis. And the moment you get 2 vectors which are perpendicular to each other, it's very easy to find the resultant. Now you have to just find the resultant of these 2. Okay, so that is how we can do it. So now we have one vector in this direction, the other vector in this direction. So the resultant now would be this one. And not only this, you can now directly write the magnitude even from the Pythagoras theorem. So it would be root of 25 root 3 minus 16 square plus 20 root 3 minus 23 square. Okay, so you direct, and not only the magnitude. Let's say if this angle is alpha, the angle made by the vector with the x-axis, so you can directly write tan alpha as this length by this length. So the length along the y was 20 root 3 minus 23 divided by 25 root 3 minus 16. So you also got the angle. So that is how we split the vector. Like that is how we split vectors into multiple vectors and then get the resultant. Okay, so I hope this part is absolutely clear to you guys. Okay, so the 4 forces that we have written, so let's check them out. So the first was 20 I cap plus 20 root 3 j cap. Let's see the components that we made. Okay, so first one was the yellow one. So 20 along x-axis and then 20 root 3 along y-axis, and therefore we are getting 20 I cap plus 20 root 3 j cap. Even if we don't want to draw the diagram, you can use I and j to write it. The next vector that we wrote was this one. Okay, and this had 24 minus I cap. Okay, 24 minus I cap, and in this direction it had 18. So 24 minus I cap, and then 18 j cap. Okay, and then the next vector is minus 12i minus 16i. So the next one was this one. Okay, so minus 12i, you can see it is in negative, and minus 16j. Okay, so minus 12i minus 16j, and the last one was this. And when we add them, okay, this is what we got: 25 root 3 minus 16 and 20 root 3 minus 23. I think we got the same result. Yeah. Okay, so that is how we can add. All right, guys. So in this session, what we have covered about unit vector. We have covered about the unit vector I, j, k. How do we use them to write the vectors? Okay, then what is the position vector? What is relative position vector? How do we write the magnitude of a vector if it is written in IJK format? How do we get the magnitude of the vector? And then what is resolution? Okay, so we have learned all these points. I hope you have understood them. If not, try to watch the lecture again at a reduced speed and you will be able to understand each and everything. All right, I'll see you again in the next session, guys. Take care. Bye bye.